Hello students, welcome back to my YouTube channel Mathematical Lens by Ganitha. In this video, we are going to continue with chapter number 7, A Tale of Three Intersecting Lines of Grade 7 Mathematics of the new NCERT textbook Ganitha Prakash. And we are going to learn construction related to altitudes of triangle. What is the meaning of the altitude of the triangle, that you'll understand here. Okay, so there is another set of useful measurements with respect to a triangle. The height of each of its vertices with respect to its opposite side. So this is the vertex, this is the opposite side, its height, right? So in the world around us, we talk about the height of various objects, the height of person, height of tree, height of building. So what do we mean by height? So here, if we consider this triangle ABC, what is the height of the vertex A from its opposite side BC, and how it can be measured, this AD, how can it be measured? So let AD be the line segment from A drawn perpendicular to BC. This is important, that it is perpendicular. It will always form a 90-degree angle over here. Should be straight, height should be straight, isn't it? Right. So the length of AD is the height of the vertex from BC. Now the line segment AD is said to be the altitude of the triangle. It is one of the altitude of the triangle. There are other altitudes also, because from each vertex there would be height. So the other altitudes, they are BE and CF. You can see here. This is the second altitude, this is the third altitude. So the perpendiculars drawn from the other vertices are the altitude. So a triangle will have three altitudes. Okay. Now, whenever we use the word height of the triangle, we generally refer to the length of the altitude to whatever side we take as a base. So, if you have taken this as a base, BC as a base, so AD would be the height. If we have taken AC as the base, B is the height. If we have taken AB as a base, CF is the height. Right? So, it should be with respect to the base. That is again very important thing to remember, right? So, if we talk about AD, then it is the height with respect to base BC only, not to AC or AB. Okay. So this is another important thing which you need to remember. What would be the altitude from A to BC in this triangle? So what is done over here? Because if you draw a straight line, it is outside. So this B is extended, and then we draw the perpendicular from A to this line. So you get the perpendicular. So here AD of the perpendicular of the triangle is in the exterior of the triangle. So altitudes can not necessary that they are in the interior, they can be in the exterior of the triangle. Altitude using paper folding. So cut out a paper triangle, fix one of the sides as a base, fold it in such a way that the resulting increases the altitude from the top vertex, right? So like here, I have taken this triangle, the cutout of a triangle, fine. And then from the vertex, we have taken this as a base. So if I fold it, the crease which I am getting, that would be the altitude of the triangle, right? So that's the activity. Now construction of the altitudes of a triangle. Construct an arbitrary triangle. So you can make any triangle. Label the vertices as ABC. So triangle ABC we have made, and we consider BC as the base, right? Construct the altitude from A to BC. Now constructing the altitude using just a ruler, it will not be accurate. You may feel that it is a straight line, it is 90 degree, but we need a more precise way. So how to do that? We can use set square, which is there in your geometry box, which we rarely use. So that is used to make a right angle. Just see here the procedure, I'll explain, and then I'll also show you by doing it. So This is the triangle ABC. This is the baseline BC. We want to draw an altitude from A to BC. So what do? We first keep the ruler, align it with the base. Then place the set square on this and place the 90-degree part of the set square, not the other angles, right? So that right angle part should touch this. And then slowly slide it. Slide it along the ruler till the vertical edge of the set square touches this vertex A. Right? When it touches here, just draw a straight line from A to BC. Fine. So this is how you get the altitude of a triangle. So now I'll show you the method. So I'll show you how to construct the altitude of a triangle. I've already drawn one triangle. We can name it as triangle ABC, one of the favorite. Now you would wonder the use of set square in your geometry box. Always you might be asking what to do with this geometry box. So today we'll use that set square in your geometry box. So what you are supposed to do to draw the altitude here from the vertex A. First, keep your ruler aligned with the baseline BC, right? This should be aligned first. Then keep your set square. First ruler is aligned, then place the set square on the ruler, right? Like this, as such that one of the edges of the right angle, this is a right angle, don't keep it this way, touches the ruler. Now slowly slide this. See to it that it does not move. Slide it, the set square along the ruler till it touches the vertical edge of the set square, touches the A, the point A, here, the vertex of the triangle, and then just draw a straight line. So this will be the altitude. The name is the point D, right? So the required altitude you can make using a set square and a ruler. Does there exist a triangle in which a side is also an altitude? Right? So you can just see the diagram. A right angle triangle, in right angle triangle, these two sides AB and BC, they are the sides of the triangle. Also, they are the altitudes because they are forming a 90-degree angle, right? So, AB is the altitude for BC and BC is the altitude for AB. So, triangles having one right angle are called right angle triangles or simply right triangles. And in that case, the side will be an altitude also, right? Or heights also. You can say them as height or altitude because they are at 90 degrees, right? So I hope you have understood what is the altitude of a triangle. We'll continue with this chapter in the next video. Thank you.